Hi guys. Okay, so we have been talking about systems of equations recently. So I think day one, we talked about kind of word problems, like how do we use these in real life. When you're going to set up a system is if you have two unknown amounts, two or more unknown amounts. We also talked about how to check solutions the other day, how to see if a solution is actually how to see if an ordered pair is a solution or not to a system. Well, we're going to actually start solving systems finally, okay? The thing with systems is there's different ways that you can solve them, which is why I love math. There's different ways that you can do math problems, okay? So the first way that we're going to show you, or I'm going to show you how to solve a system, is by graphing, okay? We just got done doing a lot of graphing, so this should come pretty natural to you today. I hope so. So we're going to write down some steps just so you have it. Okay, so how you find answer or solution to a system by graphing is the first thing you're going to do. Step one is to graph both equations. Graph both equations. Okay, so we're going to be looking at equations that are in slope-intercept form. So y equals mx plus b. So just as a reminder, and if you already know this by heart, you don't need to write it, but plot, you start by plotting the y-intercept. That's your b value. After you plot the y-intercept, you look at the slope. That tells you how much to go up or down, left to right, to rise and run. So I'm going to say use slope, which is your m, to find other points. Okay, so there's going to be two equations in a system, and you're going to graph each one of them. So you're going to have two lines on the same graph. All right. And then the second step in this is the most important step, is to actually write the solution. So write the solution. Okay, and that means answer, but really here's the key here. So maybe get a highlighter out or something, but your solution is the intersection point. So you're going to graph a line, you're going to graph another line. Wherever they intersect, wherever that point is that they cross, no matter where it's at, no matter how crazy they are, wherever they intersect, that is your solution. That's your x comma y answer, okay? Because that's where they are equal to each other. All right, so write the solution, which is your intersection point, as an ordered pair. Okay, so ordered pair is your x comma y in parentheses. Okay, so that's it for steps. So we're just going to do one ginormous example. We are going to do just one. You're going to have to make a beautiful graph in here. And then I'll show you some examples on Delta Math just so you can kind of see me do it a few times, okay? So here is your example. Okay, so obviously we have to have a system going on here. So here is your system. First equation, y equals -1/2 x plus 2. So that's the first equation in the system. The second equation is y equals 3x minus 5. So I think I mentioned this before. Most of the time, systems are going to have that little curly brace around them that shows that they're grouped together. I think it's good to get in the habit of doing that, okay? Sometimes they don't have it around them, but that's because it already tells you it's a system, okay? Anyways, get used to kind of that little brace around two equations. Okay, so steps are graph both equations. So obviously we're going to have to set up a graph. So in your notebook, I'm just going to tell you, you're going to want to go out to at least -5 on the y-axis in order to be able to graph that. Okay, so keep that in mind when you're setting up your graph. Do your little tick marks. Make it as precise as you can. Okay, pause the video if you need more time. I am going to go ahead and label. I'm going to skip count. Not skip count, but I'm only going to label every 2 points. Okay, so you can label each one. I'm just going to label every other one. All right, so let's go ahead and graph. So this first equation, we'll graph that. Y equals -½ x plus 2. So I start at the y-intercept, which is +2. So I plot a point there. The slope is -½ That tells me to go down 1, right 2, down 1, right 2. You could also go up 1, but you would have to go left 2. Okay. You take your ruler, and some of you are like, wait, solid or dashed here? Equations are always solid. It's the inequalities that you have to watch out for. Solid line, arrows at the ends. Okay. All right, now we're going to graph the second equation. Second equation has a y-intercept at -5. Ooh, totally forgot to put my little negatives. Whoops. So -5, and then the slope is 3. Remember, that's like 3 over 1. So it's going up 3, 1, 2, 3, over 1. Up 3, 1, 2, 3, over 1. Boom. That's the intersection point. 1, 2, 3, over 1. Okay. You could also go down 3, left 1. I already found exactly where they intersect, so that is great. Finish up graphing that line now. It's always important to do. So this little point right here, I want you to point at it in your notes and tell yourself that is the intersection point. That is where they cross, meaning that is your solution. So off to the side, you're going to write that the solution is, and then you're going to write that point. Is that 1, 2 or 2, 1? Careful, careful. It's 2, 1. That's it, y'all. Graph a line, wherever the intersection point is the answer. Now, here's what I want you to practice though. How could you check your answer? Not gonna have to do this every time, but how could you check to see that 2, 1 is the actual correct solution? This goes back to the last lesson. You would plug 2, 1 in for both of these equations and see if they come out as true statements. So down here, I'm gonna write a little check. So let's do this first one. What do I plug in for y? A 1 equals -½ times my x value plus 2. Plug it into the second one. 1 equals 3 times 2 minus 5. So let's see if these actually work. So over here, -½ times 2. Half times 2 is 1, so it'll be -1. -1 plus 2 is in fact 1. So it works there. Over here, 3 times 2 is 6. 6 minus 5 is 1. 1 does equal 1. So we can see that that actually is the true answer. Okay. So I'm going to show you a few more examples on Delta Math, and that's where your practice problem is going to be. So keep watching. Thanks. Okay. So here is some Delta Math little practice. So here's what it will look like on Delta. Solve the following systems of equations graphically on the set of axes below. So we're going to graph the 2 lines, and then down here we write our answer. You need to make sure that you use parentheses around your X and Y, or else Delta Math gets angry and I get angry. Okay. Okay, here we go. Y equals negative 2x minus 4. So we start at negative 4 on the y-axis. Slope is negative, so make sure it's going, down and not up. We're going to go down to right 1. So there's the first line. Second line has a y-intercept of positive 2. And the slope, look at your slope, there's no number there, so there's a secret 1, which is the same as 1 over 1. So going up 1, right 1, positive direction, positive slope. So where do they intersect? That is the whole question. So I'll zoom in for you if that's helpful. But right here is where they cross, okay? And you're not going to click on the intersection point or else the lines are going to get deleted. But as soon as you see the intersection point, you're going to do parentheses and then write the x value, which is negative 2, y value 0, and your parentheses, and there you go. Negative 2 comma 0 is your solution. Okay, here we go. Next up, start at positive 2, go down 1, right 2. Next one, we start at negative 5, up 3, right 1. This was literally the one I put in your notes. That's freaky. That's weird. So we know that the answer is 2, 1. That's funny. Okay, this next one is going to be your practice problem. So I'm going to help you graph it. All you really have to do is type the correct solution. Okay? Okay, so first one, intercept is at negative 5. Slope for that one is negative 3 halves. So I'm going to go down 3, right 2. So intercept at negative 5, down 3, right 2. Cool. Next one, intercept is at negative 1. Slope is positive half. So up 1, right 2. So I graphed it for you. Now you have to look for the intersection point and type that as your solution. Okay. That is your practice question. What is the solution to this set, to this system of equations? That's it, guys. See ya. Thanks.